Okay, geometric sequence and series. So here's a geometric sequence. And what we want to do is we want to start off by writing the explicit formula for this sequence. So to do that, we have to find R. To find R, we take the second term divided by the first term. I show that to you right here. And you get -2. Well, we know the first term, which is A, and we know the common ratio, which is -2. So we plug those in, and we get our explicit form. Okay. Next, if I want to find the 10th term in the sequence, I plug 10 into this formula. So plugging 10 in for n, and plugging this into my calculator, I get -1536. That is the 10th term of this sequence. Okay? Finding the sum of the first n terms, we have a formula for that. I wrote that formula right here, where a is the first term, r is the common ratio, and n is the nth term, or the number of terms we're summing. So a is the first term, so that's 3. 1, and the form goes 1 minus r, but since r is negative, it will be 1 plus 2, because a minus and a negative make a positive, to the nth over 1 plus 2. And then simplifying that, 1 plus 2 is 3, and the 3's cancel, leaving us with 1 plus 2 to the nth. That is the sum of the first n terms of this sequence. Okay? Since we are summing, we would call this a series, and this is what it would look like. 3 plus -6 plus 12 plus -24 plus ... plus, and then the nth term, whatever term that is that we end with, if we want to sum the first 100 terms or the first 1,000 terms, whatever that term number is. So let's say that we want to do a partial sum. A partial sum is just taking a part of this infinite sequence. So instead of doing an infinite sum, we just want to do a partial sum. So the first 7 terms, adding them together. So using the formula, first term times 1 minus -2 raised to the 7th power, because that's how many terms we're summing, over 1 minus -2. And putting that in your calculator, 129. All right, what about summing an infinite series, an infinite geometric series? So here we are again, summing them up. This time we go to the nth term, but this time we go beyond because we're going infinitely. So using sigma notation, here we are summing starting with the lower limit at 1 and the upper limit being infinity. Here's our rule. We use the formula right here, a divided by 1 minus r, for an infinite geometric series. So a is our first term, which is 3. 1 minus -2, which is 1 plus 2, which gives us 3 over 3. So the sum of this infinite series is 1. Interesting. Okay, next one. So let's say we want to just sum the first 20 terms. So starting at 1, first term, and going to the 20th term. So again, here's our rule. Here's our formula. So first term, 1 plus 2, we got 20 terms here. And then divide by 1 plus 2, put it in your calculator, and the sum of the first 20 terms, 1,048,577. Okay, what if we don't start at 1? What if we start at 5? And we want to sum the series from the 5th term to the 15th term. Well, here's our rule. First thing we have to do is find our first term. Well, our first term is not going to be 3, because that's a sub 1. Okay, we want a sub 5. So we have to plug 5 in to n. 5 minus 1 is 4. And if you do that calculation, you'll find that the 5th term is 48. That's the first term that we are summing. Okay, again, using the formula 1 plus 2 to the 11th. Now, to get n, we have to know how many terms we're summing. So what we do is we take 15 minus 5, which is 10, plus 1 for the fifth term is 11. Divided by 1 plus 2. And plugging that into our calculators, or into our calculator, excuse me, 32,784.